In this video, we will talk about sets and how to apply sets to numbers and functions. A set is a collection of distinct objects, and each object in the set is called an element or member of the set. You can use set notation to write a set by enclosing the elements of a set in braces. So for example, if A is a set of whole numbers less than 6, then A is equal to 0, 1, 2, 3, 4, 5. So it's a set of the numbers, whole numbers less than 6. That's how you'd write it in set notation. Now, when we talk about unions and intersections of sets, we need to distinguish what those mean. Okay, so a union of a set is written, the union of sets A and B is written like this. And it means it's all the elements that are in either A or B. So it's all the elements combined. So we often look at Venn diagrams when we talk about these sets. And so if this is set A here, and this is set B, then the union of the sets would be everything, let's switch to yellow, everything that's in both those sets. Okay, and so when we talk about an intersection of sets, you would write it like this. The intersection of set A and set B is written like this. Again, if we talk about the Venn diagrams here, and if this is my set A, and this is my set B, then the intersection would just be what they share. So just the elements that they share that are in both A and B. So let's look at a couple of this example here. So this example says, let U be the set of integers from 1 to 9. Let A equal the set 2, 4, 6, and 8. And let B equal the set 2, 3, 5, and 7. So example A asks us to find the union of set A and B. So if we draw out our Venn diagram here, okay, we know that U is the set of all these integers, so this is going to be called set U. Now inside set U, we have set A, and we have set B. Now, my A values, I can do these in green, I guess, are 2, 4, 6, and 8. Okay, so I can write them out here. So 2, 4, 6, and 8. Now set B are 2, 3, 5, and 7. So 2, 3, 5, and 7. So notice that both set A and set B both share 2. So I can take the 2. Oh, that's not what I wanted to do. I wanted just to erase that little 2 here. Let's see if I can do it. Oh, okay. Well, I know that we'll just cross it out now. Okay, so I know that since they both share 2, we'll just write that there in the intersection part. So when I want, so the union of set A and set B, which is what I'm trying to find here, I know it's going to be everything that's in set A and set B. Now, I have a couple things that are not, a couple numbers that are not in either of those sets. Because it tells us that U is a set of integers from 1 to 9, notice that 1 or 9, well, I'm sorry, 1 and 9 didn't belong to either set. So 1 and 9 get to hang out outside of the set out here. They're still part of set U. Okay, so my answer here, so the union of sets A and B is equal to what's everything that's inside the circles, A and B. So we have 2, 3, I'm going just from least to greatest. So 2, 3, 4, 5, 6, 7, and 8. I think I got all those right. So that would be the union of sets A and B. Now, if I want to find the intersections of these, okay, so I know this is still set U. All right, it's going to look exactly like what I had written over here. I'll I've got 1 and 9 that are still hanging out here. My set A, I'll do it in green still. We know our 2 is shared, but we have 4, 6, and 8 in set A, and set B, 2, 3, 5, and 7. There's the 2 that they share, right? 2, 3, 5, and 7. Okay, so this time I want just the intersection, just what is shared between both those sets. So it's going to be just the shared portion. So when I write my answer out here, I would say that the intersection, A intersection B is just equal to the element 2. And that's it. Now let's look at this example here. When we're talking about functions, we can write the domain and range of a function as sets of input values and output values. And then the function we can write as a set of ordered pairs. So let me show you what this means. So our domains are all of our input values. So here, I can say then that my domain is just equal to the set of, that's what my input values are, 1, 2, 3, and 4. And the same thing goes with my range. My range is my output values. So I can say that my range then is the set of the numbers 2, 3, and 4. Now, when I want to write the function as a set of ordered pairs in set notation, all I have to do is say then the function is equal to the set of, and now I just write the ordered pairs. So my input value 1, 2, write it in parentheses because it's an ordered pair. Then I have the ordered pair 2, 3. 2 maps onto 3. The 3 also maps onto 3, so I have another ordered pair 3, 3. And the last one is 4 gets mapped onto 4. So 4, 4, and I close the set with a bracket. So that is how you write set notation when you're talking about functions, as well as when you're just looking at Venn diagrams.